Hi everyone. In this particular video, so be a short video, we will look at an application in physics for work done. So you would have learned this in physics. So work done is force times displacement, which means whenever you take an object, you have to apply a certain amount of force to move it from point A to B. If you measure the force applied and the distance that you made it move, you multiply them together, really take a dot product of the vectors, then you get work done. So the dot product basically means, for example, it's easier if you carry something on your head and if you're moving straight, because if you're carrying something on your head and you move straight, grab, the weight is downward, this is 90 degrees, and the work done is almost zero, as opposed to if you're carrying it elsewhere, like if you're holding it in front or something like that. But let's look at what it means in 3 space. So work done by a force field, F. So F is a force field, which means at every point in space, there is some force that's been applied. In moving an object along C, so now we're moving it not in a straight line, but along some curve, and we want to find out how much work is done in doing this. The work done is given by the line integral of f dot t. Remember, this t vector is the unit tangent vector. So when you have a force field, which is really a vector function, every vector function has a corresponding tangent field. A tangent function, which is a vector function and can be thought of as a tangent field. And because the tangent is the direction of motion, that's why we take a dot product of the force and the tangent to then add up over the curve C to get this line integral of f dot t. T is the unit tangent vector. So the definition we have is f be a continuous vector field on a smooth curve C, which is given by a vector function r for some parameter t between a and b. Then the line integral of f along C is given by f dot dr, and we have seen that this can be written as f of the position vector dot with a derivative of the position vector, which is basically f dot tangent vector. So let's look at an example, and as we work on this, try and draw a parallel to the other examples we've done in the previous video, where we weren't calling this work done, right? So the basic difference is in the naming. Find the work done by a force field, which is described by this function. This is basically saying that it's x squared in the x direction and xy in the z direction. In moving a particle along a quarter circle, cosine t plus sine t, which is basically saying that the parameterization is cosine t sine t, just using the ij notation, where the parameter t goes from 0 to pi over 2 because it's only a quarter circle that we are dealing with. So we have a quarter circle, 0 to pi over 2, and the parametric forms are given to us. So we have f x y is x squared I cap minus xy j cap. Just as before, we got to rewrite this in terms of the parameter. Now in this case, the parameters are RT, which means the parameters are x equals cosine t and y equals sine t. So when I plug that in, I get cosine squared t I cap minus cosine t sine t j cap. And r prime t, if you take the derivative, is negative sine t I cap plus cosine t j cap. So what is the work done? Well, the work done is going to be 0 to pi over 2 f written in the parametric form and dotted with the derivative dt. So 0 pi over 2, both of these are vectors, and this we found is cosine square I cap minus cosine t sine t j cap dotted with negative sine t I cap plus cosine t j cap dt. Dot product of i's with j's becomes 0, so we're just left with negative cosine squared t sine t and a negative cosine squared t sine t from the j cap, and I cap dot I cap is 1, j dot j is 1, so we end up with negative 2 0 to pi over 2 cosine squared t sine t dt, which if you use u equals sine t, actually let's use cosine t because we have a negative, u equals cosine t and du is negative sine t. This becomes 0 to 1 to 0 u squared du. So we get 2 over 3 u cubed 1 to 0, and this is negative 2/3. Okay, so the only difference here is we're using the ij notation, right? And hence the parameters are given in a different form. Okay, so that's pretty much all for this particular topic. The following topics will have other videos.